Okay, so this is now your problem number 5. Now, the light boom AB, so this is now your light boom AB, is attached to vertical wall. Okay, so by a ball and socket joint at A. The vertical wall, so we have a ball and socket joint at point A. And supported by 2 cables.
So from the figure, we have 2 readings of the benchmark 1.
By 2 cables at B. So you have your cables BD and BC. Now, a force P, which is equal to 18I minus 24K minus 24K is applied at point B. Compute the cable tensions and the reaction at point A. So let's try to determine the tensions in the cable and the reactions at point A. So first, let us try to determine the coordinates of points. So we have your A, B, C, and D. So the coordinates of point A is, okay, this is the x-axis. So this one is vertical, that is 2, hence this is equal to 2, positive 2. Now, the coordinates of A and the y-axis is equal to 0. And the z coordinate of A is equal to 3. That is, and that one is now equal to 3. So that is the coordinate of point A. And then the coordinates of point B, your x is 0, your y is, okay, 6 meters, and then your z is 0. So this is the origin of the coordinate axis. Next, the coordinates of point C. So again, your x in here is 2. And then your y in here is 0. And your z is 6. So that is now your z, which is equal to 6. And then the coordinates of point D, so minus 4. So negative 4. And then in the y-axis, it is equal to 0. And in the z-axis, that one is equal to positive 2. Hence, these are therefore the coordinates of points A, B, C, and okay, so we now have the coordinates of the different points. So we have positive 2 for A, 0 for the y, and minus 3, that is below, okay, the origin. So B is 0, 6, 0, C is 2, 0, 6, and D is minus 4, 0, and positive 2. Let us try to draw the free body diagram of the light bulb. AB. Okay, so let's try to draw now the free body diagram of the light boom AB. So this is now your boom AB.
Okay, so syempre for the benchmark 1, they have the same elevation. So just that is equal to 205.549. And then
Okay,
for the
that is the
benchmark,
boom
the average.
AB.
So that
And we have the reaction at point A. So this is now the reaction at point A. So that is RA along the direction of the boom. That is your point A, and this is your point B. So we have your P. So this is now your P. And then we have your TBC. So it is now your TBC.
benchmark 1,
That is your TBC. And this is now your TBD. That is your TBD. Okay, so this is now the free body diagram of boom AB. Now, let us express TBC, TBD, and RA in Cartesian vector form. P is already expressed in its Cartesian vector form. So if you try to take a look in here now, for P, which is equal to 18I minus 24K. So at this point, your Px is equal to 18. So your Py is equal to 0, and your Pz is equal to negative 24. Now, let's start with the tension in cable BC. Again, the tension in cable BC is now equal to its magnitude. Multiply this one by a unit vector in the direction BC. Again, your unit vector BC is now a position vector in the direction from B to C all over its magnitude. So, the components of the distance BC are, we have the X component, the Y component, and we now have the Z component. So this is directed from B to C. So it is C minus B. So C minus B. So there is C minus B. So we have 2 minus 0. That is equal to 2. Then 0 minus 6. So we have negative 6. And 0 minus and minus 3 is equal to positive 3. So that is equal to positive 3. 6 minus 0, I mean. Okay, so this is from B to C. So we have BC, C minus B. So that is 6 minus 0. So you say 6 minus 0, or that one is equal to 6. Hence, the position vector RBC is now equal to xi. So that is 2i plus yj. So we have minus 6j and then plus jk, that is 6k. And the magnitude is equal to the square root of 2 square plus 6 square plus 6 square. And this is therefore equal to the square root of 76. Hence, your tension in cable BC in Cartesian form is now TBC. We have 2i minus 6j plus 6k all over the square root of 76. So, your TBC is now equal to 2 over the square root of 76, 0.229. 0.229 TBCI minus 6 over the square root of 76, 0.688. 0.688, that is now TBCJ plus, okay, 6 over the square root, 0.688, we have TBCK. Now, in scalar form, your TBCX is equal to 0.229 TBC, and your TBCY is equal to negative 0.688 TBC, and your TBCZ is equal to 0.688 TBC. Now, let us proceed to cable BD. So, for TBD in Cartesian vector form is its magnitude multiply this one by a unit vector in the direction BD. So, we have again your unit vector BD is now position vector from point B to point D all over its magnitude. So let's try to determine now the components of the distance BD. So the component of the distance BD, so we have your x, y, and we now have your z component. So again, the position vector is directed from B to D. So it is D minus B. So we have the x is minus 4 minus 0. That is negative 4. So 0 minus 6. That is minus 6. And 2 minus 0. That is equal to 2. Hence, the position vector RBD is now equal to xi plus yj plus zk. And its magnitude is now equal to the square root of 4 square plus 6 square plus 2 square. Or this is equal to the square root of 56. 6. Hence, tension in cable BD in Cartesian form is now its magnitude and a unit vector BD. So minus 4i minus 6j plus 2k all over the square root of 56. So that your TBD is now equal to 4 over 56 is 0.535 minus 0.535i. 6 over the square root of 56 is 0.802. J plus 2 over the square root of 56 is 0.267k. In scalar form, your TBDX is negative 0.535. Okay, TBD. So we have TBDI. So we have minus, that is 0.802. So we have your TBDJ plus 0.267. That is TBDK. So this is in scalar form minus 0.535 TBD. So you have your TBDY is equal to negative 0.802 TBD, and your TBDZ is equal to 0.267. That is TBD. Okay, for RA. So your RA is now equal to the magnitude of that force. Multiply this one by a unit vector in the direction of RA. So in the direction AB. So we have again the position vector AB is now RA unit vector AB is now equal to the position vector AB divided by its magnitude. So let us try to determine now the components of the distance, components of the distance AB. So you have your X, we have your Y, and we have your Z component. So this is now equal to, now since your RA is directed as shown in the free body diagram, it is directed from A to B. So it is B minus A. So B minus A. So we have 0 minus 2, that is negative 2. 6 minus 0, so that is positive 6. And 0 minus and minus 3, so that is equal to positive 3. Hence, your RAB is now equal to Xi minus 2i plus 6j plus 3k. Its magnitude is now equal to the square root of 2 square plus 6 square plus 3 square. And this is therefore equal to the square root of 49, or that is equal to 7. Square root of 49 is 7. Hence, RA in Cartesian form is RA times a unit vector AB minus 2I plus 6J plus 3K all over 7. So that your RA is now 2 over 7, 0.286. 0.286 RAI. 6 all over 7, 0.857 RAJ. 3 over 7. So we have 0.429. 0.429 RA. We now have K. So in scalar form, RAX is equal to minus 0.286 RA, and then RAY is equal to 0.857 RA, and your RAZ is equal to 0.429 RA. Okay, let us now apply the equations of equilibrium. Summation of forces along the x is equal to 0. So we have now your px plus tbx tbcx plus your tbdx plus rax is equal to 0. Now, your px in here is equal to 18. And then plus 0.229 TBC. So TBC minus 0.535 TBD minus 0.286 RA. 0.286 RA is now equal to 0. Let's consider this one as the first equation. Now, summation of forces along the y is equal to 0. Py plus tbcy plus tbdy plus ray is equal to 0. So your py in here is equal to 0. So we have minus 0.688, that is TBC, minus 0.802 TBD, and then plus 0.857 RA is equal to 0. So this is now equation 2. Then, summation of forces along the Z is equal to 0. So we now have your PZ plus TBCZ plus TBDZ plus RAZ is equal to 0. So your PZ is minus 24 plus 0.688 TBC plus 0.267 TBD plus 0.429 RA. And this one is equal to 0. So this is now our equation number 3. Now, if you try to solve the 3 equations simultaneously, so let's try to solve the 3 equations simultaneously. So equation 1, let's try to multiply equation 1 by 0. Let's try to eliminate RA, so that is 0.857. 0.857. So 0.857 by 0.5857 by 18 is 15.426. 0.229 by 0.857, that is plus 0.1963 T sub BC. 0.857 by 0.535 is equal to 0.4585 T sub BD. And then plus 0.857 by 0.286. So it is equal to minus 0.857 by this minus 0.2451 RA. And this one is equal to 0. So we have equation number 2. Let's try to multiply this by 0.286. So the equation will now become, okay, so this one is, okay, 0, then 0.286 by 0.688 is 0.1968 T sub BC. 0.286 by 0.802 minus 0.2294 T sub BD. 0.286 by 0.857 is equal to plus 0.2451 RA equal to 0. So in this case, we eliminated RA. So if you try to add the two equations, so we have 15.426 minus 0.0004 T sub BC minus 0.6879 T sub BD, that is equal to 0, is now equal to 0. I'll consider this one as equation 4. Okay, so again, let us try to eliminate RA using 2 and 3. So, equation 2, let's try to multiply this one by 0.429. So, 0.429 by 0.668 is minus. So, this is negative 0. So, this one is negative 0.2952 T sub BC. 0.429 by 0.802 is minus. Okay, so this is minus 0.3441 T sub BD. 0.429 by 0.857 is plus 0.3677 RA. Now, equation 3. So this is your equation 3. Let's multiply this one by 0.857. 0.857. 0.857 by 24, negative 24, is minus 1.857 times 24 is negative 20.568. 857 by 0.688 is positive. Positive 0.8848 plus 0. So this is equation 3. So we have BC is 5896 BC. 5896 T sub BC. 0.857 by 267. So it is plus 0.2288 T sub BD. And then 0.857 by 0.429 is positive 0.3677 RA. So again, for this, let us try to subtract the two equations to eliminate RA. So 0 minus, that is now 20.568. And then minus plus is negative 0.8848. 8848 T sub BC. Minus and minus. Minus minus is positive, so we have still negative 0.5729 T sub BD. So this is equal to 0. And this one therefore subtract, and this is therefore equal to 0. So let us consider this one as equation 5. Now let us try to solve equation 4 and equation 5 simultaneously. So at this time, let us try to eliminate T sub BD. So let us try to multiply equation 4 by 0.5729. So this is equal to 15.426 by this one is equal to 8.8376. 0.5729 by this is minus 0.00023 T sub BC. 0.5729 by this is minus 0.3941. 3941 T sub BD is equal to 0. Now, equation 5, let's try to multiply this one by 0.6879. So that is 0.6879. So we now have 20.568 by 0.6879 is 14.1487 minus 0.8848 by 0.857 is minus 0.6087 T sub BC minus 0.5729 by 0.857. So this is equal to 0.3941. 39, 41 T sub BD is now equal to 0. So let us try to substitute now or subtract the two equations. So that if you're going to subtract the equation, 8 minus this 14.1487, so that is minus 5.3111. Okay, so this one minus the minus that is now positive 0.60893 T sub BC. This minus and minus that one is now equal to 0. So that one is now equal to 0. Hence, your TBC is now equal to 5.3111 all over 0.60893. So that one is now equal to 8.722. So that is 8.722 kilonewtons. So let us try to substitute this equation in either equation 4 or this value in either equation 4 or equation 5. So if you try to substitute that one from equation 4, so this is now 15.426 minus 0.0004 T sub BC is 8 point. That is 8.722 kilonewtons minus 0.6879 T sub BD is now equal to 0. Then, calculate now T sub BD. So, your T sub BD is now equal to 22. So, this is equal to 22.42 kilonewtons. Okay, now let us try to substitute T sub BC and T sub BD in either equation 1 or equation 2. Okay, so from equation 2, so your equation 2 in here is equal to minus 0.688. So that is T sub BC minus 0.802 T sub AD, T sub BD, that is T sub BD, and then minus plus 0.857 RA is now equal to 0. So this is your equation 2 that was derived from summation of forces along the y-axis. So that your RA is now equal to, transpose this to the other side, so it's positive, 0.6 688. T sub BC is 8.722 kilonewtons. Transpose this to the other side of the equation, plus 0.802 T sub BD is 22.42 kilonewtons. Let us divide this one by 0.857. Hence, your RA is now equal to 27.983 kilonewtons.